Okay, let's look at question 3b. Using correct units, explain the meaning of the definite integral from 0 to 40, absolute value vt dt in the context of the problem. Then you have to approximate the value of the integral using a right-Riemann sum with the 4 subintervals indicated in the table. Okay, so for the first part, I'm going to ask you to refer back to the 2016 I think this is question 2D. It's not exactly the same, but it'll give you some perspective. It'll show you the notes that pertain to that section. So go ahead, find that video, watch 2016 question 2D, and hopefully that may all make sense. If it doesn't, then you're back here now, and we're going to talk about it. Okay? So what does absolute value of VT mean? We said absolute value just denotes total distance. Okay, so this is just the total distance that they've traveled. That's it. That's all you got to do. Okay, now if you want to write this formally, we can say the integral from 0 to 40, absolute value Vt dt is the total distance I can't spell Joanna. Joanna jogs in meters over the time period 0 to 40 minutes. And that's it. That's all you got to do for the first part. So now let's look at the second part. So the second part says approximate the value of the integral 0 to 40 Vt dt, absolute value, using a right-Riemann sum with the 4 subintervals indicated on the table. Okay, so probably the best thing to do is just to pull this up, looking at the chart. So hold on a second. So we're back here, and we're going to look at the chart. When you do this one, I should reference what I want you to look at. When you're doing this one, I want you to refer back to 2016. Look at question 1b. Okay? Very similar question. 2016 1b is going to be a left. This is going to be a right. We're going to approach it the same exact way. So pause it now. Take a look at it. Kind of give you a hint because I drew a chart here. I was about to draw a picture here. But go ahead and pause it, look at it, see if you can figure it out, and if you're still confused, you're back with me. So, what are we going to do here? Well, I'm going to draw a picture here. This is going to be T, this is going to be VT, and I'm going to plot the points. So we have 0, 0, here's 0, 0, then I have 12. I'm not really picky about how I label these. I have 12 and 200. Here's 12 and 200, and then 20 and 240. Okay, nothing's really drawn the scale, doesn't matter. Next is 24. Now keep in mind with 24, because we are taking the absolute value, it becomes 220, positive 220, because we are taking the absolute value. And the next one, I'm just going to move this T away, draw that line out. What are we on? 40. There's 40. And the last value is 150. Okay? So we got a graph that looks something like this. And we are taking right Riemann sums, which means I start from the right side and I draw my rectangles. Right side, draw my rectangles. Right side, draw my rectangles. Right side, draw my rectangles. Okay? And so if I'm going to calculate this, and you don't have to draw the picture, but if it's confusing, draw the picture. The base is 12. The height is 200 for the first one. Right? Then the base is 8. The height is 240. Then the base is 4, The height is, that's a 220. And the base, 24 to 40, is going to be what, 16? And the height goes here. We said this was 150. All I got to do now is add these up, and I win. So 2400 plus 8 times 24, which is going to be 1920 plus 880 plus 16 times 150, which is 2400. So we add these up, and we end up getting 7600. And let's refer to our units. We are doing this. So this is meters per. So if you look here at your unit, this is meter per minutes times minutes. So when you multiply meters per minute times minutes, you end up getting the minutes to cancel out, so it's just meters. So my final answer is in meters. And there you have it. So hopefully you're seeing that these problems are not very different from the ones we did in 2016, and things are going well for you. Alright, see y'all in the next video.